Hello, am I audible?
Yes, sir.
Hello, okay. So, one thing is, suppose observation, suppose a ring A contains, or R, I should write R, a ring R contain an idempotent element, say uh, this is non-trivial idempotent, that is not, this idempotent is not zero or uh, non-trivial idempotent, contains non-trivial idempotent elements, say E, that is equals to 0 and 1. Then what happened? Idempotent means E square equals to E. E square equals to E. This implies 1 minus E equals to 0. Now 1 belongs to 1 minus E generated ideal plus E generated ideal, as 1 equals to 1 minus E plus E. 1 means 1R. I should write R. Then what happened by Chinese remainder theorem? A isomorphic to A mod 0. 0 means, what is 0? 0 means 0 ideal. E 1 minus E, that is isomorphic to A quotient E generated ideal cross A quotient 1 minus E generated ideal. Okay, so A isomorphic to product ring. Again, isomorphic.
Sir, you have taken R instead of A.
Oh, I have write R, right? Okay, so I have to write here R. Thank you. R, R, R. So there is a problem. 1 R minus. So so R is isomorphic to a product ring. Product ring R1 cross R2. R1 is generated ideal and R2 is generated ideal. Okay. Conversely, if R isomorphic to R1 cross R2, now my question is R1 R2 are sovereign of R1 R2 is subset of, can be seen as subset of R? It is yes also. So I one more observation, that R ER so I write here,
দাদা রেকর্ডিং চলছে তো?
yeah, হ্যাঁ চালিয়ে দিচ্ছি
হ্যাঁ,
R2, হ্যাঁ চালিয়ে দিচ্ছি,
ঠিক আছে ঠিক আছে।
ER multiplication is E. What is kernel? X goes to EX. What is kernel? Kernel is of this map is what is those x such that Ex equals to 0. That means what is kernel? Tell me. 1 equals to E plus 1 minus E, right? So x equals to Ex plus 1 minus Ex. Now Ex 0. If and only if x equals to 1 minus Ex. This implies x belongs to 1 minus E generated ideal, and okay, x belongs to kernel E, x belongs to kernel E if and only if Ex 0, if and only if x is that, if and only if x belongs to that idea. Okay. So last line, if x belongs to 1 minus E generated ideal, then what happened? If x belongs to x 1 minus x generated ideal, then what happened? Just do the computation. I write here this simply okay. Now this part, if x belongs to 1 minus E generated ideal, then see 1 minus E goes to where? I write here the map, I write theta E, okay, to avoid the confusion. I write here theta E. X belongs to kernel theta E. Now theta E of 1 minus E, what is this? E into 1 minus E, that is 0. That means 1 minus E subset of kernel E theta E, right? Here kernel theta E subset of 1 minus E generated ideal. So exactly R mod, so exactly kernel is 1 minus E generated ideal. 1 minus E generated ideal. By the first isomorphism theorem, so R mod 1 minus E generated ideal is isomorphic to image, but image of theta is it is surjective map, because if you take E x, then pre-image is x, isomorphic to ER. Okay.
So thus it is the subring of R.
So ER is contained in R, right? Conversely,
Yeah.
yes. Similarly, it similarly what? Uh, Similarly, R mod ER isomorphic to 1 minus R. Okay. Now conversely, if R isomorphic to R1 cross R2, then what happened? Then take 1 0, E equals to 1 0, then E square E 1 R1 comma 0. There is take E equals to E square equals to 1 R1 comma 0 equals to E. So non-zero, so R contain non-zero idempotent. Now one one thing should be noted, that R is isomorphic to product ring, that is no problem. But if we take in my definition that rings are assumed to be 1, number 1, and in homomorphism 1 goes to 1, then this part should be removed. Okay, this part. So you cannot see R1 and R2 as a subring. Okay, but in some text they are not assumed that ring should contain 1 and 1 goes to 1. They in that setup it can be seen as subring. Okay, so that's why I remark here as a, I put here as a star. In my definition it is not ring homomorphism. ER is not subring. ER is an ideal generated by E. So ideal is not isomorphic to whole ring, because in my definition ring should contain 1. Okay, and ring homomorphism 1 goes to 1. So in my setup you can say that if R contains a non-trivial idempotent, then it is isomorphic to product ring, but this R1 R2 cannot be seen as subring. Subset cannot be seen as subset of R. Up to isomorphism it is okay. Okay, 26. Now I start with some discrete problem. Probably you have heard it. Let us I want to discuss rings of fractions or localization. Before going to that section, I want to discuss some discrete problems. Number one, find all dense subfield of C. This is a very good problem of Artin. So how to approach? Hello. Answer. Let F subfield of C.
ডেন্স মানে টপোলজিক্যালি ডেন্স।
Yes, closer is F closer is C.
আচ্ছা,
A subfield of C. Okay. Now, what is the characteristic of F? Can you tell me? 1 belongs to here, F also. So, finite times 1 cannot be 0 because characteristic C is 0. Okay. As character C is 0, this implies characteristic F is also 0. Okay. Now you know that if a field huh?
না এটা থেকে ওই বলছি ওই প্রাইম সাবফিল্ডটা পেয়ে যাব কিউ।
Yes. Therefore Q subset of F, because any field of characteristic 0 contains Q as a subfield. Now if F subset of R, then F closer subset of R closer, and that not equals to C. Therefore hence F is not dense. If F not subset of R, then R minus F minus R non-empty, pick alpha belongs to minus R. This implies imaginary part alpha not 0. Since dimension this implies 1 alpha is a linearly independent over R. Since dimension, vector space dimension R over C is 2, 1 comma I is a basis, you know. This implies 1 alpha is the basis of C over R. This part check, just linearly independence check. So any Z belongs to C, there exists A B belongs to R such that it is a basis, so Z can be written as A into 1 plus B into alpha, that is equals to A plus B alpha. Now Q is dense in R, all of you know. So there exists a sequence, rational sequence xn and yn such that limit xn equals to a and limit yn equals to b. So limit xn plus alpha yn equals to a plus b alpha equals to z. Therefore as Q subset of F and alpha belongs to F minus R, this implies smallest field containing Q and alpha is subset of F. So what is happening? Q alpha closure equals to C. Okay, because the xn plus alpha yn, as xn plus alpha yn belongs to Q alpha for all n belongs to natural number. Subset of R. What is Q alpha? Q alpha is the smallest field. Q alpha is the smallest field containing Q and alpha. Okay, this implies Q alpha, this is subset of C also. Q alpha closure is subset of F closure is subset of C, that is C. Q alpha closure C is subset of F closure subset of C, that means F closure equals to C. Hence F is dense. Therefore my question was find all dense subfield of C. So all dense subfield of C are the subfields which is not contained in R. Okay, so if F is a subfield, and converse is also true, because if F is a dense, then F cannot contain in R. If F contained in R, then F closure is not C. Okay, so F is a subfield of C suppose, or let f is dense in C, you can now leave f minus r is non-empty. Okay, so this is one problem. Another, again a discrete problem sum. Let definition let S1 and S2 be R algebras. Phi S1 to S2 is said to be R algebra homomorphism if phi restricted to R. You can think that R is R algebra means there are map, right? There are map R to S. There are map R to S. So here you can think, I write specific way for this problem. R algebras as R is a subring of both. That means R to S1 there is inclusion morphism only. If phi restricted to R is identity, so you have S1 S2 R sitting inside, R sitting inside here also. So you here is phi restricted to R is identity. Okay, this is called R algebra homomorphism. So my problem is also an artin problem. You can find in artin books. I forgot which problem, but there is. Find automorphism k of kx where k is a field. I think some of you know the problem. What do you mean by kx? That means you have to find phi kx to kx auto. 1 minute, just 1 minute. Hello. Okay. So you have to find all automorphism phi kx to kx such that phi restriction k is identity. So any guess? At first give some example of automorphism. Ring automorphism. Okay. Note that note that x goes to ax.
এটা বোধহয় এসএন হবে না?
Yes. What is?
Isn't this supposed to be SN?
What is Sn?
মানে symmetric group over n alphabets.
See, please. Ax plus b. AB belongs to k. A not equals to 0. Is it automorphism? Yes, because uh, is an automorphism, k automorphism. I should write k automorphism. R algebra, that is similarly k automorphism. With there you check this. This is automorphism. Now, so phi kx to kx phi ab, I write this way, ab x goes to ax plus b such that ab belongs to k with a not equals to 0 is subset of odd k kx. I write it is as sigma. So it is sigma is subset of odd kx. Now let phi be any automorphism. Phi then phi inverse
kx, sir.
also, yes,
Kx,
loud,
k square bracket x.
yes, then phi inverse also belongs to odd k kx. Now let suppose phi kx to kx, x should goes to some polynomial and maybe constant, maybe I don't know, x is the element of phi x is the element of kx, so it is a polynomial, and phi inverse also x goes to some some gx. So phi inverse compose phi of x, that is equals to x, right? That is what is phi inverse of phi x means fx, that is g of fx. Let gx equals to a0 plus a nx to the power n with degree g equals to n. Then gfx a0 plus a n fx to the power n. If degree f equals to m, then degree of gfx, what is it? Mn, right? As kx is integral domain. But gfx equals to x, comparing from this line, x equals to gfx, degree we have mn equals to 1. This implies m equals to n equals to 1. So fx is linear. Equals to ax plus b, where a not equals to 0. If a0, then degree is 0, but degree is 1. Therefore phi equals to phi ab and that belongs to sigma. So what? Therefore ought kx is equals to sigma equals to phi ab, such that ab belongs to k. I have defined what is phi ab, so I am not writing in elaborate way. Okay, so this is again a classification of automorphism of one variable. Now question is getting much harder if I take what kxy. At first check that problem let let us consider kxy to phi kxy to kxy, x goes to x plus fy, where belongs to ky and y goes to y. Then show that phi belongs to ought kxy. This type of automorphism is called tame automorphism. It's called tame automorphism. So this is easy. So x goes to x plus some polynomial of y, and y goes to y. Or you can permute this, y goes to y plus fx and x goes to x. Same type of things. So what? How to show it is automorphism? At first, have you understood what I am saying here? Suppose you have a polynomial this type, x square y plus y cube something plus x to the power 5 y squared, this type of fxy. Suppose I write pxy, pxy. So tell me, what is 5pxy? Have you understood what is this? You just put here this type of writing is called a style of k algebra or R algebra, whatever R algebra, ring homomorphism. I can write this type. So
Instead of x, we will put x plus fy.
yeah, right. Fy to the power square, y should goes to y cube plus y to the power 5 y square. So this is just example. So I want to show you that this is automorphism. Okay, construct this is not part of the proof. Start from here. Psi, this is very easy problem. X goes to x minus fy and y goes to y. Then y compose psi of x equals to phi x minus fy equals to x plus fy. As y goes to y, fy should remain y, so x, and phi compose psi y, it is no problem. Phi of y, it is y, and conversely psi compose phi of x goes to psi x plus fx, sorry, fy x plus fy, x minus fy plus fy, that is x, and psi compose phi of y is psi of y, that is y. So you see that psi is inverse, is the inverse of phi. Okay, so therefore phi is automorphism, hence phi belongs to aut k kxy. Now let T is the subgroup, T is the subgroup of what k kxy such that generated by all tame automorphism. Okay, so you can take many plenties of fy, x goes to x plus fy, y goes to y, or you can take x goes to x, y goes to y plus fx. Okay, so this type of automorphism you take all collection and generated by generate subgroup. Okay, so T is the subgroup of what kx generated by tame automorphisms, all tame automorphisms. Then result without proof. This is for just for knowledge. Result T equals to what kx. Vanderkolk. So over two variable, it is unknown, it is a conjecture. Nagata conjecture is T is not generated by this. T not equals to, sorry, what kxyz. Okay, and for three variable it has proved now by Shestakov Umirbai. So whatever, leave it. I am interested for you this this from this these two line are beyond of your syllabus. Okay, just for your knowledge. Now
Sir, the T also will be constructed by fixing the polynomial depending on x also. Here x plus fy, and we also can take y plus fx type.
yes, yes,
That is
either
okay, okay.
it goes to x plus fy, y goes to y, or it x goes to x, y goes to y plus gx. Okay,
Okay.
this
Okay.
type of automorphism you have plenties of fx, fy, so you have large collection. So this is some. Now next question is, can you construct discrete question, just can you construct a field, sorry, can you construct a ring with local ring means one maximal ideal, right? Can you construct a local ring? You have said that you have said in first class, or you said that take a maximal ideal R, m maximal ideal, it is m to the power r, it is a local ring. Okay, now my question is, can you construct a ring with 5 prime ideal and exactly 5 prime ideal or and 2 maximal ideal? Can you construct? Arbitrary, I'm given arbitrary number 5 prime ideal and 2 maximal ideals. So this type of construction I need some more result of localization. Okay, let R be a ring. S is said to be let A subset of R is said to be multiplicatively closed set if multiplicatively closed set if number 1 belongs to S and S1 S2 small s1 s2 belongs to S imply S1 comma S2 I write ST product belongs to S. Example, this is definition. Example, please give me example. Let F belongs to R. Take S equals to 1 F square. I write 1 R dot dot dot. That means F to the power n, F to the power n such that n greater equals to 0. এক দুই if P belongs to spec R, then R S is a multiplicatively closed set. Then R minus P, S equals to R minus P is the multiplicatively closed set. So these are examples, very easy examples. Now take construction. Take S cross R or R cross S, I write. Take R cross S. Define a relation curl on R cross S in the following way. A S related to BT if there exists U belongs to S such that U into AT minus BS 0. Okay, check that this is an equivalence relation. Curl Now notation, A by S is your class of AS, equivalence class. Okay. Sigma, or I write S inverse R is A by S such that A belongs to R, S belongs to S. Okay. Note that if 0 belongs to S, then what happened? A by, then just 1 minute. Hello.
Yes.
Okay. If 0 belongs to S, then what happened? Take any A by S, then A comma S is related to 0 comma 1, as for any A belongs to R, S belongs to S, as 0 into AT. AT means A dot 1 minus 0 into S equals to 0. Therefore S inverse R equals to only 0 by 1, because all elements are related with 0 1, so it is trivial. Okay, if 0 belongs to S, then it is trivial. So no, I have not given a ring structure yet, so it is trivial set. Now define trivial set means a singleton set, only 0 set. Notationally define plus S inverse R cross S inverse R to S inverse R, just pronunciation S inverse R. So elements of this set is A by S. A belongs to R, S equivalence class of AS, where A belongs to R, S belongs to S. A by S, B by T goes to AT plus BS by ST, and dot S inverse R to S inverse R, A by S, B by T goes to AB by ST. So claim plus and dot are well defined. Answer. Let A1 by S1 related to right. Some a1 by s1 equals to a2 by s2. S1 b1 by t1 equals to a2 by s2 by t2. This implies a1 s1 two class are same if and only if they are related, right? Equivalence class s2 and b1 t1 related to b2 t2. So there exists, by definition of relation, u1 u2 belongs to s such that u1 a1 s2 minus a2 s1 0 and u2 b1 t2 minus b2 t1 equals to 0. So you have to show that a1 t1 plus b1 s1 by s1 t1 equals to a2 t2 plus b2 s2 by s2 t2. So you have a1 s2 t2, right? a1 s2 t2. So this is 1, this is 2. a1 s2 t1 t2. u2 t1 t2 is 2, I write, or a2 s1 into 1 and u1 I write s1 s2 into 2 and add. So what happened? u1 u2 t1 t2 a1 s2 minus u2 t1 t2 a2 s1 plus little bit calculation u1 u2 s1 s2 b1 t2 minus u1 u2 s1 s2 b2 t1 equals to 0.
So in the second term, I think there will be u1.
What?
In the second term, I think there will be u1.
There is u1. Okay. So a1 I am just following the cross multiplication. Okay, a1 a t1 s2 t2 plus b1 s1 s2 t2. What is remaining part? Remaining part is a1 t1 t2 s2, remaining part is u1 u2 t1 t2 s2. One, two, three, four, u1 u2. Okay, now here v1 s1 s2 t2, remaining part is u1 u2. Okay, minus s1 a2 t2 s1 t1 a2 t2 s1 t1 minus b2 s2 s1 t1 equals to 0. So this imply these two fellows are related. Okay, a1 t1, this imply class is well defined. Similarly you can check that dot is also well defined. Now a by s plus 0 by 1 equals to a that is a by s, and a by s 1 r by 1 r is check that S inverse R plus dot is a ring, is a commutative ring. Actually I also show that a by s into b by t equals to ab st equals to ba, because ts equals to b by t a by s, so it is commutative ring. Okay, a belongs to r, s belongs to s, ab belongs to r, st belongs to s. So is a commutative ring with identity. You see that 1 r by 1 r is identity and 0 by 1 r is additive identity, zero element of this ring. Now my question is, what is the nil radical of S inverse R? So before answering this question, you have to answer what is spectrum of S inverse R, what are the ideals of S inverse R, right? Example, take sorry, this is just ring. R equals to Z and P equals to 0. You know that Z is integral domain, therefore 0 is the prime ideal. So you see that here, if P belongs to spectrum prime ideal, then S equals to R minus P is the multiplicatively closed set. Okay. Therefore, I write Z minus 0, a multiplicatively closed set. So what is S inverse R? Equals to S inverse Z, I should write. A by B such that A belongs to Z, B belongs to Z minus 0. What is this? This
Q.
is notationally denoted by, we denote notationally by Q. Okay. So this is an example. You can take S equals to 2 to the power n, take S equals to 1, 2, 2 square, this type of. What is S inverse Z? A by 2 to the power n such that n belongs to natural number. So it is denoted by Z half. What is Z half? Zx, what is Zx? Set of all polynomial coefficient coming from Z. Now what is Z half? Now evaluate x by half. Then elements are said to be Z half. So elements look like a0 plus a1 half plus an to the power n. Now add it, then you get a by this form. Okay. Next day, it is a very important concept, localization. Next day I will discuss some problem, and at first I will discuss localizations, universal property and etc. Then we will go to some problems, and after localization I will go to three very interesting ring: Euclidean domain, PID and UFD. Okay. If you have any question, please ask me. Otherwise, today I will stop here.
হ্যালো।
হ্যাঁ,
আচ্ছা বলছি সব জায়গাতে প্রাইম আইডিয়ালটা মানে স্পেকট্রামটা এত ইম্পর্টেন্ট কেন হয় মানে কোনো রিং এর স্টাডির জন্য?
অ্যাকচুয়ালি আমরা এরপরে যখন জাইস্কি টপোলজি দেব, মানে আমরা অ্যালজেব্রিক জিওমেট্রি স্টাডি করতে চাই। অ্যালজেব্রিক জিওমেট্রি এবং অ্যালজেব্রিক্যালি ক্লোজ ফিল্ডের উপর দেখা যাবে যে আমরা এই প্রবলেমটা করব, যে হিলবার্ট নুস্টেলেঞ্জাস বলে একটা থিওরেম আছে, দেখা যাবে একটা পয়েন্ট সি টু দি পাওয়ার এন এর একটা পয়েন্ট আর ম্যাক্সিমাল আইডিয়াল সেম। ঠিক আছে, তো ম্যাক্স স্পেকট্রামটা খুব ইম্পর্টেন্ট। তো গোথেন্ডিক আরেকটু এগিয়ে গেছিল, উনি স্পেকট্রামের উপর টপোলজি দিয়েছিলেন, হ্যাঁ, যেটা জারিস্কি টপোলজি, সেম টপোলজি, জিরো সেট নিয়ে গাইড। এবার সেইখানে আমরা জিওমেট্রি স্টাডি করি, তাই স্পেকট্রাম জানা খুব দরকার।
আচ্ছা।
তো বিগার গোল আছে, তো ওগুলো রিগোরাসলি পড়তে হবে। মোটিভেশন সামটাইম অফ থিংস এরকম যে পিছনের রিগোরাস জিনিসগুলোকে আমরা লুসিডলি, মানে নন রিগোরাসভাবে একটুখানি গল্প শোনার মতোভাবে বলবো। তো সেরমভাবে ভাবতে গেলে আমরা পুরোপুরি অ্যালজেব্রিক জিওমেট্রি, নাম্বার থিওরি, নাম্বার ফিল্ডগুলো যদি দেখো, হ্যাঁ, তো সেই এইসব মানে কিউতে সবসময় সলিউশন পাওয়া যাচ্ছে না, তখন আমরা কিউ কিউ কমপ্লিশন মানে প্রাইম আইডিয়াল দিয়ে নিই আর কি, জেড কমপ্লিশন প্রাইম আইডিয়ালে। তো সেই সব জায়গাগুলো আর কি, সেই সব ফিল্ডে আর কি সলিউশনগুলো বেশ ভালো পাওয়া যায়।
মানে ম্যাক্সিমাল আইডিয়ালের জেনারেলাইজেশন যেহেতু প্রাইম আইডিয়াল একটা সেন্সে, তো সেই কারণে প্রাইম আইডিয়াল
না না,
এর
আমি
একটা সেন্স।
জেনারেলাইজেশন নয়, ওটা হলো যে আমি ম্যাক্স প্রাইম আইডিয়ালের সেটটা নিলে ম্যাক্সিমাল আইডিয়াল তার মধ্যে ঢুকে আসছে, সাবসেট।
হ্যাঁ, ওই সেন্সেই আর কি বলছি তো।
হ্যাঁ, তো আর সব রেজাল্টগুলো ভালো স্টাডিও করা যায়, এগুলো করবো পরে যদি তোমরা এগো তো।
স্যার,
হুম।
ইনফাইনাইট প্রোডাক্ট আগের দিন যে কোয়েশ্চেনটা
ইনফাইনাইট
জিজ্ঞেস
প্রোডাক্ট নিয়ে
করছিল।
পরে কথা বলবো, আপাতত ধরো ইনফাইনাইট প্রোডাক্ট অফ জেড নিয়েছো, তার মধ্যে এক্স 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 করে যাও, এক্স একটাই এলিমেন্ট,
হুম,
এইটা দেখো তো আইডিয়াল হয় কিনা।
আচ্ছা।
হুম, আর এইটা ওই টাইপের আইডিয়াল হয় কিনা দেখবে। ইনফাইনাইট পুরো রিং নিয়ে আমি পরে কথা বলবো, জাস্ট কোশ্চেনটা তুলে দিয়েছি, নেসেসারি সব কিছু একসঙ্গে সলভ হোক, বুঝেছো? কী কী কোশ্চেন থাকতে পারে আমি বলছি,
ওকে।
ঝামেলা আছে ওখানে, বুঝেছো? তোমাকে আমি জাস্ট একটা জিনিস চেক করতে বললাম, ওইটাও করতে পারবে। আর কোনো কোশ্চেন আছে? ওকে, তাহলে আজকে রাখছি। ইফ ইউ হ্যাভ এনি কোশ্চেন প্লিজ আস্ক মি।
স্যার আপনি মানে কোন বই ফলো করছেন? মানে আজকে আমি প্রথম ক্লাস করছি।
বই ফলো? বই তো আমি কিছু ফলো করছি না, বুঝলে?
আচ্ছা ঠিক আছে। আচ্ছা
তাও
ঠিক
তুমি
আছে।
পড়তে পারো যদি বই চাও, আর্টিন দেখো, হাঙ্গারফোর্ড,
হ্যাঁ
ল্যাং, সার্চ ল্যাং, মোটা বইটা, গ্র্যাজুয়েট টেক্সট অ্যালজেব্রা, কিন্তু
হ্যাঁ বুঝছি।
হ্যাঁ, কিন্তু ওইগুলো পড়তে গেলে কি একটু, আমি একটু শর্টকাট ওয়েতে তোমাদের নিয়ে যাচ্ছি, ওগুলো অনেক বেশি বেশি আছে, তো এইগুলো ব্যাপার। আমি এমন এমন
ঠিক
জায়গা
আছে।
দিয়ে যাচ্ছি, এইটা পড়লে যাতে তোমরা নিজেরা বাকিটা করে ফেলতে পারো, হ্যাঁ, তো সেটাই চেষ্টা করছি। সব আছে ওই ওই বইগুলোতে, সবই আছে, কিন্তু অনেক টাইম লেগে যাবে পড়তে।
হ্যাঁ স্যার, তাই দেখলাম।
ঠিক আছে।